So I'm going to show you again a little bit more about the if statements that we had done previously, and the way we're going to do that is by changing the control, and I'm going to change the way the crab moves. So I'm going to go into my crab code, so you might as well do the same. And we'll walk through this process with the crab, and we'll talk about some things that you could do as well. So in here, what I'm going to do is go down to the way this crab walks, and this is how we did it when a computer player was walking. So now again, a good thing about having this method is if I'm about to change the way the crab walks, I know exactly where to go. I go into this method, and this is the only part of my code I ever need to worry about. So now if I want to completely redesign the crab, I go into this method, and anybody else who asks about crab walks, they would only have access to that crab walk method, so they would automatically be updated with the new version of the crab. So in here, what I'm going to do is connect them to the keyboard instead. And I'll just, again, we're going to get in this habit of getting to documentation. So if you don't already have a copy opened up, you should have one available. And the basic standard Greenfoot classes come under this package. It'll show you all of them in there. And then these are the ones that are standard. So in Greenfoot, this is what we're going to take a look at today. Is if you were wondering about what kind of keys you can use, here's the different key names that you could use. And down here, there's a whole pile of information about different utilities. This is the one we're going to check for today. Is a certain key down? So I'm going to go back to my code, and this is the feature that I'm going to add in. So what I'm going to say here to give you an idea is if Greenfoot.isKeyDown, and the key I'm going to look for this time is going to be the left key. So if somebody is pushing the left key, then what I would like you to do is turn towards the left. So if you think about the way that this turns, positive is clockwise and negative is counterclockwise. So that means maybe I want to say turn -5. So let's have a look and just see how that's connected, because we can observe this actually happening in the scenario. And I'll add a crab to the world once it's there. And the only thing that the crab will do is respond to the left key. So every time I hit that left key, it rotates a little to the left. So we're going to expand on this a little bit. And what do you think would be the next logical thing to want to add to its behavior? Turn right, thank you. So it's good to know there's some logical people in this class. So is the key down? And we're asking about the right key. If you're not sure how to ask for the key, it's in the documentation. So left, right, up, down, those sort of keys are spelled instead of using the up arrow or whatever else you might think they are. If you want to know, for example, are they touching the space bar? It's space. Do you want to know if the P key is down, etc.? So for us, we're now talking about the right. So it means I'm going to end up turning this crab to the right. So now I can make him rotate by the keys. And I'm also going to want to be able to do forward and backward, because right now I only have a crab that can turn. So basically this crab will get dizzy, but he'll never go anywhere. So let's fix that as well. I'm going to say if Greenfoot.isKeyDown up. Now, this time what I'm going to do is, instead of calling move, which makes the crab move in the direction it's facing, I'm going to go beyond that. The move method comes from the animal class. So if I was to look at the animal's code, I would see the move method. There's another move method in actor which specifies how much you want to move. So remember, you would get all of these methods in addition to the move method that you find. And this one tells me how far I'm going to push the crab. So what I'm going to interpret this as is when you push up, I want you to move in a positive, so forward direction. So here, that's what I'm going to call upon, is I'm going to say move, and we'll just say 1. Then down here, if you are holding the down key, I'm going to apply the same logic. However, now I'm going to move by a negative. So I'll run this just so you can see how the crab behaves now and what these if statements will do, plugging it onto this new crab. Now when I add a crab to the world, I can go left, I can go right, I can go forward, backward, and for crabs, forwards and backwards are left, actually kind of more like left and right, because of the way they would move on a beach, I guess. You don't see too many crabs moving right in a direction ahead. They have to move left to right. But I actually have some movement now that I can manipulate with the keyboard. And again, if you don't like the movement that's here, that's your job as the programmer then to define a better way of moving your crab. So I'm going to peek back into this code here for the crab. And we're going to talk about other ways we could do this. So let me just get a quick survey. Hands up. This is a difficult thing for a game user to manipulate. If you're playing the crab, would you find it hard to use this crab as your character? Okay, head nodding is fine if you don't want to put your hand up. So let's talk about other ways we can move an object. Another way you can move an object is through the set location method. So what I'll do here is I'm just going to blank out this code. And we're going to do the same thing, except we're going to, instead of turning it and calling move, we're going to take control over where the next spot is the object goes. So instead of saying turn, I'm going to say set your location. And to move something to the left, that means what I want to do is wherever you're located now, what I would like you to do is take your current position and subtract 1 from your x coordinate. So it goes like this. That's my current position. And what I'm going to do to move left is subtract 1. So if I want to move right, I'm going to add 1. And this is the first bit of computer graphics that may change on you. When we talk about up and down on a computer screen, it's slightly different than what you would expect. If this window right here that says crab, if this window was my computer screen, we're used to saying that the coordinates, maybe the mouse here is 0, 0, and we would go positive x, positive y, negative x, negative y. We were used to those things. However, on a computer screen, the top left corner, right there, that corner is always 0, 0. And x is as you would expect. Positive x, negative x. But the y coordinate is upside down. This is positive y, and this is negative y. So when you go negative, you're actually going up. And when you go positive, you're actually going down. So that's the only thing that you have to keep in mind. And this is consistent and true across all computer graphics that I know of. So it is a bit of a learning curve to begin with to remember this fact. But it is consistent and you will see it everywhere. So let's change this now to move up. That means I need to know where you are. And I'm going to subtract 1 from your y coordinate, because subtraction on the graphics screen moves you down. And here we're going to say set location +1 to move you. give you the appearance that you're moving down. +1 will move you towards the bottom of the screen. So now what I'm going to do is I'm going to go compile my crab here, and then we'll take a look at how this behavior has changed. And I'm not going to tell you that it's perfect and that it's an amazing character to use. That's part of your job here, is to take what I do and make it better, or what you think could be an improvement. But now if you look at the way the crab moves, this is probably more like what you would expect. Do you notice what I've lost about the ability of this crab? Yeah, it doesn't turn itself anymore. So all it does is move up, down, left, right. That's not to say that we couldn't add the behavior of turning the crab, but again, that would come with more programming. So there's a basic crab moving. Now another feature that students like to use in Greenfoot is adding some sounds, and that's what we're going to do now. I'm going to show you this feature because it basically goes back to the same topic that we're talking about here, which is how to write an if statement. So what I'm going to do here is go to where the crab eats. So when that crab looks for worms, it eats one of these worms. And now I'm going to add a sound effect to that worm. So it's a good thing to know about is how does Greenfoot save your projects. So what I'll do is I'll bring up my projects. So I'm here in the CrabWorld, the little crab. So when you save a scenario, this is what it looks like inside your scenario. All your Java code, all the things that you add to the world get put in here. And this isn't super important to remember at the moment, but you might as well know a little bit about what these are. This file right here, the .java file, that's your source code. That's what you typed into Greenfoot. This .class file, this is the bytecode that we talked about, which Greenfoot takes your sort of pseudo-English language, Java, turns that into something the virtual machine can read. So if you were to look at this .class file, it would look like nothing that resembles anything, you know, coherent. It would be a bunch of bytes and all kinds of crazy stuff. But that's some of the structure you have. The important thing for you to know about as using this in your game is this folder for images and this folder for sounds. Basically, all the resources in your game should be included in your same folder. That way, when you want to move your project around, everything goes with your project. The documentation that you're learning about, we're going to talk about how to create it another day, but it would be in this documentation folder. So if you're working on a team of programmers and you're saying, you know what, guys, we need to start documenting what we're doing so other programmers can use it, this is where you'll find it. But if we want sounds, this is where we can store them so Greenfoot knows how to find them. And we're going to use that slurp right there. If you add different images, different characters, look at that. There's the images and characters in our game that we've been using so far. So that's where you can store new images, new actors. And you might not have noticed that, but we actually have a new background there. Okay? So I'm going to go back here to my code. And when I eat a worm, I'm going to go down and say greenfoot.play sound. And what I want you to play is slurp.wave. So now it's going to go into my sounds folder, and it's going to find this file, which is called slurp.wave. And you can see down here the property is a wave file. So I should hear something. So as long as I've got my sound connected properly, which I hope I have, we should be able to now observe this behavior when the crab eats the worm. So I'll put it in here, and when I play this scenario, let's see if we can hear it. I guess I better make sure I'm at full volume before we... Yeah, okay. Oh, there you go. So there's obviously some lag in mine as I'm recording, but it would be more instant in yours. But I don't know if you heard the slurp, it definitely was there. So one handy thing I'm going to point you to for looking for sound effects, there's all kinds of sites where you can track down sounds. you know, if you have a specialty thing in mind, like Super Mario Brothers, you're probably best to Google search Super Mario's sounds. But one that's pretty useful that you may want to take a look at is freesound.org. And for example, if you want to add some new sounds, let's say you've got like a bomb explosion, right? A bomb blast of some kind. You can search through free sound and download these clips. So, for example, I can go, what's a blast here? And there we go. Here's a bomb blast. And I can preview it before I go for some download. So depending on how picky you are, you may or may not like that as part of your game, but it's one place you can go and get generic stuff. Otherwise, like I said, you'll have to do a Google search for specific sounds. It's good to be aware of what's supported. So if you go to the documentation and you look at play sound, it'll tell you these are the file formats that Greenfoot can read. If we needed to do anything beyond that, we would have to talk about other ways of adding your sound or converting it over to a WAV file as a way of doing it. Okay. The last thing I want to do in here is show you a bit of behavior, because this is going to come up in your programming assignment. So the first thing I want you to think about is, I find this crab is slow. When I move them, I find it slow. So watch what I have to do as the programmer to make this code go faster. So far, I'm a pretty good programmer because I have a method that controls the movement. So I know that if I'm going to change the movement, it all happens in here. So this is how I locate it, and I have to go, but look at this. I've got 4 different places to fix this. So let's say that I wanted to make this go faster, meaning I'm going to move farther. And let's say I'm careless and this is what I did. Does anybody see a problem so far with what I've done? If I'm about to start compiling this, what's the problem? That's right. Greenfoot is key down is different. So I'm glad I didn't have to sing that Sesame Street song for you guys. You know, one of these things is not like, no? Too old for that now? One day you'll have little kids, you'll hear it again. So yeah, I've missed one. And this is the point I'm going to illustrate for you now. This is why we call them magic numbers. They're numbers that another programmer might say, why'd you pick 3? What's the significance of 3? It's sort of magical, just showed up. And if I want to change it, I have to be very careful. Like maybe there's a good reason it's supposed to be a 3, and I'm not allowed to change it. Maybe when I do change it, it's all goofed up now because they're different amounts. So as a programmer, one good way around this is to use a variable. So what I'm going to do is change the way this crab behaves. I'm going to make this crab have a speed. So the speed is something that belongs to the crab. The crab knows how fast it's going to be. So let's go up here and we'll add a method and we'll add some instance variables. So what I'm going to do is say private int speed. And I like this habit of putting an underscore after that instance variable because it's not just any old integer. It is something that stores information about a crab. So I'm hiding this from people because I don't want them to mess with the speed. I'll allow them to change it and do things, but I'll show you how that works in a second here. So what I need to do is give this speed a value. And when we give it a value, we always initialize in our constructor. So a constructor, remember, has the same name as the class. So I'm going to say public crab. And a crab extends an animal. So believe it or not, the first thing I should do before I start making a crab is I should make an animal. And classes above me are called superclasses. So this is how I say, ask the person above me to do its job. So before you can work on a crab, you got to build an animal. And that's what I just did. Now I have access to all of the animal things. Now Java will complain if you don't make the first line of your constructor the parent. So it may not always look exactly like this, but you should always call for the parent to build a object for you first. And now that I've done that, I would like to say, let's start with my speed at 1. This is the default speed for a crab. Now when I have my speeds down here, that's what I'm going to change. So now I've got speeds happening as a variable, things that I could change now. I don't have to, if I want to change speed, it'll do it automatically for me because it refers to the same variable. I only need to change speed one time, and everybody who should be affected automatically updates. That is good coding. That avoids using those magical numbers where you're not sure if you're allowed to edit them, or if you forget it, it could make your code run poorly. So there's no difference in the behavior of the crab yet, so let's add that difference. What I'll do now is I'll let you change the speed of the crab, and the way I'll do that is I'll say public void set speed. And this is a method that allows a person to tell me, please make this crab move at 10, I don't know, steps. They tell me what the speed is. I will then change the speed that I have. So here I say speed is equal to the one you gave me. I might also want to know what speed is the crab moving at before I change it. So we can also allow someone to see what the speed is, and we'll say get speed. That means if you want to know what the speed is, I have to tell you an integer, like maybe the speed is 5. If the speed was 5, I would have to give that back to you, and the way you say it in Java is return. So if somebody wants to know what's the speed, return this integer. So this is the first time we've looked at it. It's not going to settle in until we program and code and practice a little bit, but here's just a quick reference to how you can do this. And we'll go and observe it in Greenfoot so you can see it actually happening. Okay, so now when I'm going to compile my crab, I'll show you this behavior. We'll add a crab to the world. And now when I run it, nothing's really changed, but I can pause the simulation and say, how fast are you going? I am at the moment moving with a speed of 1. Okay, so why don't we then say, let's see what happens if I change your speed to 5. Now I can ask and I can change. And if I now run it, my crab's going to move a lot faster. So maybe I think this is more appropriate as far as what it should react on the keyboard. Okay, so now I've given more customization. I can change the speed how I like. This crab also does something else that I want to keep track of. So I've got a worm in the game, and the crab's job is to eat the worm. So why don't we keep track of how many worms that the crab has eaten, and that's the last feature we'll add today. So how I need to do that is, again, the crab has to keep track of how many things it's eaten, just like the crab keeps track of its speed. So up here, I'm going to make another variable, and it's also an integer called worms eaten. When I build my crab, I haven't eaten any worms yet. So I'm going to say worms eaten equals 0. This is the way I initialize that variable properly to tell you, hey, this crab just was created. It couldn't have eaten a worm yet. But there is a spot that I know when it has eaten a worm, and that's down here. So when you eat that worm, you should tell me that I've eaten a worm. So this says update the number of worms you've eaten to be 1 more. Okay? Now there is a problem here. the crab is going to keep track of it, but it's not going to tell anyone about it because it's hiding it. It's private. The crab is holding on to the number of worms it's eaten, but it won't let anyone see it. Now, generally, this is a good thing because we don't want people messing with the number of worms eaten. The only time the number of worms eaten changes is when the crab eats a worm. We want that behavior to be consistent. And the only way you can guarantee that that happens is if you don't allow anyone to use worms eaten, because then they could change it when a worm wasn't eaten. So what I'm going to do instead here is allow you to see it, but not change it. So public int get worms eaten, and return how many worms I've eaten. So if you're doing a game that involves some kind of challenge where you have to collect things or destroy things, now I have a mechanism for tracking how many the character has done. So maybe the level's over when this crab eats 10 worms. Now I have a way of knowing how many it's eaten and when to stop the game. So I'll just show you that behavior before we leave today's lesson. But now if I put a crab in the world, I've got keyboard control, I've got sound, and I should be tracking how many worms I've eaten. So right now, how many worms have I eaten? It would say none. I've just been born. But now when I run this game, and I'm going to go over to the worm, and now I can ask that crab, how many worms have you eaten? It should say 1. Okay. So there's a lot of stuff in there, and I promise we're going to spend a good chunk of time practicing these ideas. So let's talk about your responsibilities going forward here.